Now it's time for Line Gordon. And Line has known also Buzz for quite some time now and been also heavily engaged in the Resilience Alliance and has been trying to address the whole complex issue of freshwater management and ecosystem services in dynamic landscapes and how the resilience approach and the management of those resources comes into your picture. So, very welcome, Line.
Okay, thank you, Carl, and thanks a lot to Buzz also for the enormous inspiration that the type of work that you have been doing over the years has inspired me tremendously. And I will, that's sort of what I'm going to talk about here today. I'm not going to talk about the general things that Buzz has contributed with, but some of the work that I've been involved with and how I have been inspired by these ideas. And I realized also, listening to the speakers before me, that some of the most inspiration has been in terms of really trying to be creative in doing science, daring to be more experimentative in the way that we engage in science, and not be too limited by sort of some of the rigor that science also needs. But I think that's a very important lesson that I have gained from your work. But what I will talk about today is both about water resources, in the context also about food security, and a little bit in the development context. So when we think about water resources today on this planet, I think most of us in here, I think everyone in here are aware that we have a planet which is very water scarce, and that water scarcity is a major problem today. But on the other hand, I think most of it has been analyzed very much from a partial perspective. And from this type of perspective, we know very well how much accessible water resources we have on the planet and how much we use out of those resources in terms of irrigation, industry, households, into society. And that some of that water use are lost because it is consumptive water use, it goes back to the atmosphere, while some of it is a return flow that goes back to rivers, etc. Over the last few years, another water user has also been added to this perspective, and that's water use by nature. But I think this picture that most people are working with are seeing water very much as a commodity. It builds on linear thinking, where water is seen mainly as a finite resource, that also sees water use by nature as competitive to society, and very little feedbacks involved. And I think that has been a major problem in hydrology. Today we live on a planet where agriculture is more or less filling the whole surface. About 40%, somewhere in between 35 and 40% of the world's surface is today agriculture, under agricultural practices, in terms of croplands or grazing lands. The land use of agriculture has increased dramatically. You see here on the first graph, from 1700 to 2000 in terms of pasture, croplands, and irrigated agriculture. Water use for irrigation has also increased dramatically over the last 100 years. And nutrient use in agriculture has also increased dramatically, causing lots of problems with eutrophication of lakes and rivers. In this type of world, we need a new perspective of water. And this is something that Malin Falkenmark has pointed out several times, where we see water not only as a commodity, but as a bloodstream of the biosphere, and where we try to account for the different types of interactions that water have in different systems. And I would say that the mental view of water so far has primarily been in the rivers and aquifers section of the whole hydrological cycle, and therefore missing a lot of the important interactions that water have on this planet. And especially when thinking about this agricultural expansion and how it alters water flows also to rivers and aquifers and up to the atmosphere. In order to be able to better account for these interactions, Malin Falkenmark and Johan Rockström came up with the term of green water flow. That's basically evapotranspiration, the flow of water that goes from the ground and through plants back to the atmosphere. We did an analysis a few years ago about how much humans have modified this flow of water to the atmosphere. And what you see on this picture is the green areas, and the colored areas are agricultural land. Red areas are where the green water flow to the atmosphere has decreased because of deforestation in order to have agriculture in those deforested lands. And the blue is where it has increased because of irrigation. When you look at the amount of change, irrigation has increased the water flow with about 1,800, 2,500 cubic kilometers per year, while deforestation has decreased the water flow with around 3,000 cubic kilometers per year. So globally, it more or less average out. But the spatial pattern are different. This led us to sort of look into what kind of consequences can there be from these type of changes. And some of the regions that fall out is the Amazon region that Johan already talked about, where 50 to 60% of the evapotranspiration are recycled into rainfall, and where clearing of large areas of the Amazon can lead to this sudden shift between a rainforest type of ecosystem to a savanna-like ecosystem. It has to be pretty large-scale clearing, though, for that to happen. But on the other hand, there is a huge process of clearing going on there. The Sahel area is another area which has also been suggested to have this type of rapid shift between more vegetative states and less vegetative states. And of course, this is super important, as most of the population in this region are dependent on rainfall for their whole survival, because they're so dependent on local agriculture. On the other hand, there is also other driving forces behind these shifts in vegetation and rainfall patterns in the Sahel that are competing with clearing of land. There are suggestions that the Indian monsoon system is very vulnerable to changes in evapotranspiration, as well as the East Asian monsoon systems. After having done this, we were really interested in if we have these shifts in the atmosphere, the risk of these shifts, are there other shifts in ecosystems that can be driven by agricultural expansion and what it does to the hydrological cycle? So we went through the literature to look for where can we expect these shifts to occur. And we looked at, what we found was that some of these shifts are shifts that occur in downstream ecosystems, eutrophication, hypoxic zones, and river channel shifts. Some are shifts that occur in the soil. This can be salinization of soil, which has happened in Australia, shift in vegetation pattern, and also destruction of soil structure. And then some of these shifts have to do with the atmospheric recycling of water. Most of these it's driven by agriculture of water, but it has also other effects driving it. So climate change interacts with agricultural expansion, hydrological change. If you look at the scales where these shifts occur, you can see that they do occur over a wide variety of scales. And they're also possible to restore at different temporal scales. One of the interesting things that we were struck by when we did this analysis is that the clearest evidence for these shifts are of the shifts that are in this sort of intermediate scale where you have at the watershed or landscape scale or the river basin scale, while the weakest evidence are on the larger scale and the smallest scale, the soil structure scale. And I would say the larger scale is not so weird because we haven't been able to experiment at that scale, and maybe I guess we shouldn't. But at the smaller scale, I think a lot of the focus has been on more optimization type of approaches where this type of analysis hasn't been done. But that's one of my hypotheses. So how do we build resilience? Well, some of the suggestions that we had is that we need change in perceptions and management, looking much more at heterogeneity, more on functional diversity, dynamics, and a much broader sense of the hydrological cycle.